What's up guys, Musi Gamer here, and this is the first episode of my new series, Mind Bomb. And this series is all about, you guessed it, blowing your mind. Now I've always had a huge love of science and concepts that boggle the mind, and I love learning new things and ideas. And so, I decided why not make this into a thing? And I did, and you're watching that thing. Anyways, I'm gonna stop rambling because it's time to have your minds blown with numbers. Big numbers. So how big is a big number? What do you consider a big number to be? 100? 5,000? 200 million? 47,873,162,484,561 Sure, those might be rather large compared to numbers we use on a regular basis, but they are nowhere near the size of a little number called a Google. No, not the search engine, although they did get their name from the number. So what is a Google? Well, in 1938, mathematician Edward Kastner created the idea of an unimaginably large number, a 1 followed by 100 zeros, or 10 to the 100th power. He wanted a name for this number of his, to which he asked his 9-year-old nephew Milton to come up with. For such a seemingly outrageous number, Milton suggested giving it an equally outrageous name, and thus Google was born. Now exactly how big is a Google? Well, imagine that you decided that you wanted to sit down to a steaming hot plate of a Google waffles, stacked on top of each other. How big might that stack of waffles be exactly? Well, a stack of a Google waffles would be somewhere in the range of about 10 to the 80th light years in height, which would be about 10 billion trillion times the size of the known universe. Still not convinced? Well, what if I told you that the number of individual grains of sand on Earth comes nowhere near a Google? There are only about 10 to the 19th grains of sand on the planet, a number insignificant when compared to a Google. There's not a Google stars in the known universe, which is approximately 10 to the 24th, still quite small compared to Google, and there's not even that many subatomic particles or quarks and leptons, which make up protons, electrons, and neutrons and atoms in the known universe. That number is believed to be about 10 to the 80th, which is a rather large number on its own, but still a very long way from a Google. But there are most definitely numbers that far exceed Google. One example of an even more insanely enormous number would be a Googolplex. No, not the name of the Google search engine headquarters, although they did get its name from the number. There are some clever dudes down at the Googolplex. Anyways, so a Googolplex is basically like Google's big cousin on steroids, or a 1 with not 100 zeros behind it, but a Google zeros behind it. Yeah, and you thought a Google was huge. Now if Google was so large that it was pretty much impossible to imagine, how big could a Googolplex possibly be? Well, if the entire universe was filled with nothing but paper, and all of that paper had zeros written all over them in size 10 font, it would only be half of the zeros required to write out the monstrous number that is a Googolplex in long form. Since it's even strenuous having to write the number as a power of 10, you have to use a power tower to represent it, which would look like this. 10 to the 10th to the 100th power, or 10 to a Google power. Now by this point you might be thinking that there can't possibly be any number larger than a Googolplex. Well, prepare to be sorely mistaken. Ladies and gentlemen, I give you Poincare's recurrence time. This number is believed to be the longest finite length of time ever explicitly calculated by any physicist. Now what is this even more incomprehensible number? Published in 1890 by mathematician Henry Poincare, it's the amount of time that it would take any system, often referring to the universe, to return to a state that is about the same as today. So basically, the amount of time it would take for history to literally repeat itself. To be able to better understand what that means, imagine a 2D image. Now imagine slicing and squishing that image hundreds of times, turning it into a snow or random noise. Well, when the process is repeated thousands of times, the original image eventually reappears, although sometimes with greater or lesser bits of noise along with it. But eventually, the image would completely or at least almost completely return after enough repetitions. So what is this number? Well, it looks a little something like this. 10 to the 10th to the 10th to the 10th and to the 10th to the 1.1 years. Yeah, don't think about that too much. But of course, none of these numbers even come remotely close to infinity. But that's a mind bomb for another day. So I hope you enjoyed this video and that your mind was blown as much as mine was. And let me know what you think of this new series in the comments below. So this has been Musi Gamer, and I love you, a Google!